We just derived this relation here, the relation between the differential of the speed of the rocket sled and the differential of the mass of the rocket. And we want to ultimately get the speed of the rocket. So we have to apply a technique called separation of variables, and then we want to integrate. What we're going to do is first we're going to multiply by dt, so that falls away, and we're left with mr dvr equals dmru. And we're going to shuffle the m onto the other side, and we're left with dvr equals, u is a constant, so that goes up front, and then we have dmr over mr. That's an equation that we can integrate now, and we can do that. And the tricky bit is that we need to take care of the integration limits here. We have VR, and actually these now are all primes. So we have VR going from V naught, that is our initial condition here, to VR prime of equal VR of t. And for the mass, we have mr prime equals m naught. Actually, not quite m naught, it's 2 m naught, because the initial mass of this is the dry mass and the fuel mass, so that's 2 m naught. So this is the initial mass. And then we go to mr prime equals m of VR. All right, so let's do that. We're going to get VR minus V naught equals u 1 over m integrated gives us an ln. So ln, and then we can immediately do this here over 2m naught. And well, we ultimately want this, so this is an VR of t, of course, and then we get V naught plus u ln mr over 2 m naught. And that is our equation.
Go ahead.
So what does this equation tell us? Mr, the mass of the rocket, is less later on than it was before, which means this term here is going to be less than 0, which means the velocity is our initial velocity minus something, which means we have a decrease in velocity, which means my sled will eventually come to a stop.